Write one question. Species. Can you hear me?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, thank you. Species. Species. H2, HCO3 minus HSO4 minus NH3. Species can act both as Bronsted acid, can act both as Bronsted acid, and Bronsted base. For each case, give the corresponding conjugate acid and conjugate base. Corresponding conjugate acid and conjugate base. So you have to write their conjugate acid, and conjugate base. To get conjugate acid, you have to put one H plus. To conjugate base, you have to remove one H plus. So this is the species given. To get conjugate acid, I am going to add one H plus to this. So H3O plus. H plus I added, it was neutral. When I added one H plus, it has got plus. To get conjugate base, I have to remove one H plus from here. This is already neutral. When I remove one H plus, then what is remaining? Minus. So here, OH minus. Okay. Now this species, add one H plus, subtract one H plus. When I add one H plus, this is already has got a minus sign. If I add H plus, it will become neutral. So H2CO3. Now from this, subtract one H plus. I am removing one H plus from this minus. So CO3 to minus. Plus and minus neutral. Next one, I am adding one H plus. So here H plus, this is already minus. When I added H plus, that plus and minus become neutral. So H2SO4. Now I am taking out one H plus. So when I take out one H plus, one minus will remain there. And here already one minus is there. So 2 minus. So SO4, 2 minus. Now NH3. I'm going to add one H plus. This is neutral. When I add one H plus, NH4 plus. When I remove one H plus, then NH2 minus. So these are the conjugate acids. These are the conjugate base. These are the conjugate bases. So that's about Bronsted acid and Bronsted base. Next is Lewis acid and Lewis base. Nothing. The species which is having one lone pair of electron available, one pair of electron, available electron. So this one pair of electron can be donated to the other species, to other fellows. So such species which are having a pair of electron is called Lewis acid. which accepts that pair of electron, that is Lewis base. For example, NH3. This is Lewis base. NH3 has got one lone pair ready to give, available, one pair of electron. So this is Lewis base. Lewis base. A species which can accept that pair of electron, that is called Lewis acid, AlCl3. AlCl3, you know, Al around Al3 Cl. Only 6 electron around Al. Octet is not complete and it has got vacant d orbitals also. So it can accept pairs of electron in that d orbital. So we say AlCl3 can accept a pair of electron. AlCl3 is a Lewis acid. So write some other Lewis bases. OH minus, H2O. H2O has got two lone pairs of electron. Two lone pairs of electron. H2O can give one lone pair of electron during the reaction. So it is a Lewis base. Lewis acid, AlCl3, BF3, BF3, boron trifluoride, BF3, boron trifluoride. So these are Lewis acids and Lewis bases. So three types of acids and bases we have seen. Arrhenius acid in terms of H plus and OH minus. Then Lowry-Bronsted, or simply we can say Bronsted acid, Bronsted base. Bronsted base means giving Bronsted acid means it can give H plus, and that H plus is taken by, accepted by a Bronsted base. Bronsted base. Next we are moving to ionization of. So we have seen acids and bases. Now we are going to see ionization of weak acids. The chapter is equilibrium. Equilibrium exists only in the case of weak acid, your weak bases. If it is fully dissociated, nothing is remaining on the reactant side. So no equilibrium. Equilibrium word exists only in the case of partial dissociation, partial, not complete dissociation, not complete ionization, only partial. So we are going to touch weak acids and weak bases. Weak acid, for example, CH3, COOH. Generally, we show HA for acetic acid. HA, acetic acid. So here, A minus means acetate and CH3COO minus, H plus proton. So acetic acid, by putting in water, all molecules of acetic acid will not dissociate. Only a few molecules will get dissociated. Only few molecules will get dissociated. The molecules which undergo dissociation will be in this format. H plus, but that H plus will be combining with this H2O to form H3O plus. That's it. This is aqueous, aqueous. So here, this is liquid. Water is in bulk, so we don't have to consider the concentration of this water. So CH3COOH acetic acid is a weak acid, means weakly dissociating, means only very few number of acetic acid molecules undergo dissociation to form CH3COO minus and H plus. The formed H plus will be combining with this H2O to form hydronium. That only what we have written, hydronium. So here, there are some acetic acid which are undissociated. So they will be in equilibrium with the dissociated ones. Dissociated and undissociated. Equilibrium is there between these two. So you can write an equilibrium constant Kc. Here it is for acid. So I am writing A, acid. A, Ka. If it is for base, I will write Kb instead of Kc. Ka is equal to concentration of CH3COO minus into concentration of H3O plus. Here it is 1, here it is 1. So here 1, 1 divided by here remaining CH3COOH. Remaining CH3COOH. This is for Ka. For weak acid, we will write Ha plus H2O in equilibrium with what, A minus plus H3O plus aqueous. So there you can write a case. Kc means we are telling Kc now Ka because we are doing for an acid. Now let's see if it is a base. If it is a base. Weak base, you may not be knowing weak bases. HF is a weak base. Or NH2 bond NH2, hydrazine. NH2 bond NH2 is a weak base. Everything you have to put in water. Water is a good dissociator. So, what I am getting is, now this is the base, this is the acid. So, acid will give H plus sign. What will remain here? OH minus. OH minus will remain. This is the acid here. This will act as the acid because we have already said this is a base. So here OH minus, so H plus will be taken by this fellow. So this will be NH2 bond NH3 plus. Water is in bulk, so I'll write like it. Here Kc, but instead of Kc, I'll write Kb because it is a base. Kb is equal to this is remaining NH2. Don't take that original amount what is given. Suppose they say 0.1 molar hydrazine is taken. Don't put that value here. उसमें से कुछ गया. What is remaining? That remaining amount you have to put here. Okay. So one example you saw for weak acid and one example you saw for weak base. HF is a weak acid. These amines, heroin, cocaine, nicotine, these things are bases, weak bases. Next, we are moving to one concept that we have to learn, that is ionic product of water. You take any solution, as acidic solution, basic solution, or neutral. In that, if there are H plus ion concentration and OH minus ion concentration, the product of these concentration is equal to 10 to the power minus 40. You take any basic solution or acidic solution or neutral, this water, H plus ion concentration into OH minus ion concentration is equal to 10 to the power minus 40. Sometimes H plus ion concentration is more, then we say the solution is acidic. Sometimes OH minus ion concentration is more, we say basic solution. Sometimes both are equal, then we say neutral. Consider our ordinary water. We say water is neutral, neither acidic nor basic. If I take water in a beaker, so many H2O molecules are there. So many H2O molecules are there. So I'm writing H2O, H2O, two H2O molecules. One will act as an acid and the other will act as a base. Suppose this is acting as an acid, that means this give H plus to this. So this is accepting that. Bronsted acid, Bronsted base. One is acting as an acid, one is acting as a base. So here, this H2O accepts one H plus, means here H3O plus is formed. What is remaining? That is OH minus. OH minus. So here you can write Kc. Kc, here I am writing, I am replacing C by Kw. Kw, that is the product concentration of those things. Change will be only in the less amount, not in the bulk amount. Bulk amount change is not a change. So this is called ionic product of water. This is water is neutral, Kw. Anyway, Kw, this product is equal to 10 to the power minus 40. 10 to the power minus 40. Kw is equal to 10 to the power minus 40. It is very difficult to handle this minus, minus, minus thing. So we will be making into a small number, just like 14, 6, 5, 7, 8, like that. We will be making that into a handy number. So for that, we are taking negative logarithm of Kw. So Kw is equal to 10 to the power minus 40. Negative logarithm of Kw, which is equal to negative logarithm of 10 to the power minus 14, which is equal to 14. This minus Kw is called pKw. So we will be talking pKw. pKw. For acid we will say pKa. For bases we will say pKb. Because these numbers are very handy numbers. Handy numbers. So pKw. For acid pKb. pKw, for acid pKa, and bases pKb, like this. These terms will be using. This is like small number, not like 10 to the power minus something, something, something. So these are handy numbers. Now let's see. This into this is equal to this, that is 10 to the power minus 40. For pure water, for pure water, H3O plus into OH minus is equal to 10 to the power minus 40. I'm taking negative logarithm on both the sides. That is negative logarithm of H3O plus into OH minus is equal to negative logarithm of 10 to the power minus 40. Right? So, what is negative logarithm of H3O plus? I am writing separately. Negative logarithm. Oh, chalk is good. Negative logarithm of H3O plus. Now again, log A into B is equal to log A plus log B. So negative logarithm of OH minus is equal to, what is that? 14. 14. Log A to the power n is equal to log A to the power n is equal to n log A. So here, negative logarithm of H3O plus, that is pKa. pKa, this is H3O plus hydronium ion, plus this is pKb, that is pKb is equal to what is 14, that is pKw, that is pKw. So pKa plus pKb is equal to pKw. Or you can say this pK H3O plus you can talk as H plus also. Hydronium ion is same as hydrogen ion. So we can write it as this pH plus POH. pH plus POH is equal to pKw. pH plus POH is equal to pKw. That is 40. pKw is equal to pH, hydronium ion concentration. Hydronium ion concentration, pH plus POH is equal to pKw. Write one question. The concentration of hydrogen ion in a sample of soft drink. The concentration of hydrogen ion in a sample of soft drink is 3.8 into 10 to the power minus 3 molar, capital M. What is its pH? What is its pH? What is its pH? What is pH? pH means negative logarithm of hydrogen ion concentration or negative logarithm of hydronium ion concentration. What is pH? pH is, see, this is pH. Negative logarithm of hydronium ion concentration. Yeah, negative logarithm of hydrogen ion concentration. The question is only for pH. Question is only for pH. So here pH is equal to negative logarithm of hydronium ion concentration. Yeah, hydrogen ion concentration. Negative logarithm of what is given? 3.8 into 10 to the power minus 3. 3.8 into 10 to the power minus 3. That is negative logarithm. Log A into log B is equal to log A plus B. Log A plus log B. Log A into log B is equal to log A plus log B. Monday onwards, you should have that logarithm table with you. I think it is given on the last pages of your textbook. Maybe in that green colored textbook, the last pages. You check whether it is last pages or the first pages. Maybe the last pages. There you will see logarithm table. So keep it open. So log A into B is equal to log A plus log B. Log B. If you have, open it right now. You have that green textbook with you? Take the textbook. Taken? Last pages. Columns are there. Logarithms, anti-logarithms, like that. Can you see? Okay. So minus log 3.8, then minus log 10 to the power minus 3. That is minus log 3.8, 3.8 plus 3. That is log 8 to the power n is equal to n log a, that is minus 3 into minus, that is plus 3, log 10 is 1. Log 10 is 1. And minus log, this is a single digit number. This is a number between 2, this is a number between 3 and 4. This is a single digit number. How many whole numbers are there? That is 3. How many whole numbers? We say digits. How many whole numbers? So 1. So raise 1. To write that, we say characteristic. For that, जितना फिंगर्स खोला है उसमें से एक कम कर लेना. अगर 3 खोला है तो एक कम कर लेना. 4 खोला है तो 1 कम कर लेना. 5 खोला है तो 1 कम कर लेना. एक खोलना, open, that depends upon the digits here. How many digits? Whole number. That is 3, 1 digit. So 1. Open 1. एक कम किया तो 0. So minus 0 points. So suppose this is 498.8. That means 3 digits. 3 digits. 3 digits. A kam karna. So we write 2. This we call it as characteristic. Characteristic. So here 0 is the characteristic. Now beginning say 2 numbers. Beginning say 2 numbers. You should keep it together. That is 38. 38 का 0th column देखना in that logarithm. We will continue in the next class. Now this will not get over. Thank you.
Thank you, ma'am.
We'll continue this. So all should keep that green book with you. Last pages.